Hi, I'm George and I will be demonstrating nvshare, a mechanism which enables practical GPU sharing without memory size constraints. It is practical as it is easy to set up and is transparent to user applications, as it requires no code changes. Additionally, it enables each collocated application to utilize the entire GPU memory. GPUs are essential for accelerating machine learning workloads, which include throughput-intensive training, latency-sensitive inference, and interactive development, which is a special case. Let's take a look at the workflow of an ML scientist working on a Jupyter notebook. First, they write their code in a cell using either TensorFlow or PyTorch and submit it for execution to the backend. The backend calculates the results and displays it to them, and subsequently, after some time has passed, during which they refactor or debug their code, they run a different cell, and so on and so forth. Cloud orchestrators, such as Kubernetes, enforce a one-to-one GPU to job allocation policy. This leads to massive GPU underutilization, especially for interactive tasks. In this example cluster with 3 GPUs and 6 users, only the first 3 users manage to grab a GPU and run their Jupyter notebooks. The other 3 are left pending. Now, when 2 of these 3 users decide to go to take a break or refactor their code, the GPUs are idle. But why would Kubernetes do this? Why not let more users share the GPU? Examining the default CUDA memory model will answer a question. Let's assume we have a GPU with 12 GB of memory. To access data on the GPU, apart from allocating CPU RAM, user A also allocates GPU memory by calling CUDA-malloc. Each byte allocated through this method must be backed by a byte in physical GPU memory. This creates memory contention, as user A and user B both compete for the same pool of physical GPU memory. So, at one point, user B gets a fatal out-of-memory error. This is because in the normal CUDA memory model, allocations are FCFS, there's no memory oversubscription, and there are no pagefulls. To see this in practice, let's run 2 ML applications in parallel, each using 5 GB of GPU memory. As the GPU has a capacity of 8 GB, the sum of 10 GB does not fit, and the second application gets a fatal out-of-memory error. The runtime for one application is 84 seconds approximately, so running one after another, which is our only choice, would take 168 seconds. CUDA also offers the Unified Memory API, which is not widely used. When a user allocates memory through CUDA-malloc managed and later accesses it on the GPU, a pageful triggers and the Unified Memory subsystem fetches that page to the GPU. This means the GPU memory can now be oversubscribed, meaning that user B can also utilize the entire GPU memory by evicting pages from user A. This employs an LRU replacement policy. The key idea behind nvshare is to transparently enable GPU pagefulls. We do this by converting every normal CUDA memory allocation call to its unified memory counterpart. In this way, we can collocate 2 users on the same GPU. When user A is idle, user B fetches their data to the memory and computes normally, and vice versa. We need to keep in mind that when both users want to compute on the GPU, nvshare must serialize their GPU parts to avoid thrashing. As a result, the number of collocated processes is now limited by system RAM, and each process can use the entire GPU memory. Let's now see how nvshare allows running the 2 previous workloads whose sum of working sets does not fit into GPU memory in parallel. To install nvshare, we first clone the repo. Then, we enter the source code directory and build. Then, we move the shared library to the correct location so that it can be preloaded into user applications. And finally, we install our scheduler binary. We start our scheduler and our workloads. When the working sets, as in this case, exceed physical GPU memory capacity, our scheduler serializes the overlapping GPU bursts from the collocated applications to prevent thrashing, while letting the CPU parts run freely in parallel. Keep in mind that these are training jobs with no idle periods. For interactive jobs with idle periods, the benefit is immeasurable. Let's see the total completion time under nvshare.